All right, here we go. Question number 1 from our Precalculus homework number 3 in MyLab Math. We're going to be using a guided visualization. It says in the applet that'll launch when we click the link. The graph of f of x equals c times a to the x minus h plus k is drawn. Now, I have written that over here in my scratch work a little bit bigger so you can see that more clearly. It says use the sliders to set the value of c to 1, a to 2, h and k both to 0. Then it says use the slider to increase the value of a from 2 to 4. Note the points on the graph, and then we need to complete parts A and B. So what I wanted to start with is I want to actually show you what's going to happen to this function when we plug in the values given. So if we replace c with 1, a with 2, x minus h is 0, and plus k is 0, that function will simplify to just simply 2 to the x, because 1 times anything is itself, so the 1 times disappears. X minus 0 is just x. Anything plus 0 is itself. And so we can see that f of x is going to be just 2 to the x, which is what they mention in part A. It says graph the function f of x equals 2 to the x. And then we're going to generate the y values when x is negative 1, 0, and 1. All right, so here we have our applet open. We're going to set our values. First, c sets to 1. A is already set to 2 in my window. H and k both need to be set to 0. And then if you look right here, it's going to say f of x equals 1 times 2 to the x. Remember, 1 times anything is itself, so that gives us our f of x equals just 2 to the x. And then we can look at our ordered pairs to look at the y values that are going to be generated. So let's list those over here in our scratch work. If x is negative 1, y is 0.5. If x is 0, y is 1. And if x is 1, y is 2. Now, I simply copy and pasted these ordered pairs showing up in the graph. If we wanted to take a more in-depth approach, what we could do is plug in for x, negative 1, 0, and 1, and verify these y coordinates. Okay, so first, 2 to the negative 1, if you input that in a calculator, it may give you a half, which is the same as 0.5. So 2 to the negative 1 is a half. Next, 2 to the 0 power. Remember, anything except 0 to the 0 power is going to be 1. And then 2 to the first power. Anything to the first power is itself. So that will give us our 2. And that's the way you can get those ordered pairs algebraically, by doing plug and play into the function. All right, so plugging into our MyLab math, negative 1 is 0.5, 0 was 1, and 1 was 2. Part B, graph f of x equals 3 to the x, and then give the y coordinates for the same x coordinates. Okay, so back to our app. If we want to graph f of x equals 3 to the x, notice what's going to have to change is the value of a. You can see over here in our scratch work that whatever a is gives us the base. So if we want 3 to the x, then we're going to have to change a to be 3. So sliding that over to 3, we can see how the y coordinates change for those x values. All right, so now with our updated f of x equals 3 to the x, filling in the y coordinates, we're going to have 0.3 repeating. I know in the graph here it says 0.33, but that 33 is going to continue forever. So that's 0.3 repeating. You can use the bar notation, or you can write down the value that they give in the picture. When x is 0, y is 1. When x is 1, y is 3. And again, if we want to figure those out algebraically, we simply plug in for x, negative 1, 0, and 1, and then evaluate those. You should get the same y values. And here we go, plugging in. We're going to do the 0.33 because if you read, it says rounded to 2 decimal places, so that indicates they want the 0.33. And then when x is 0, y is 1. When x is 1, y is 3. And that's going to do it for this particular question. So if you have any questions or comments about anything covered here, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.